So for question 7 and 8, we need to we are supposed to read this data priorly. L is equal to 4 pi d square b. We don't know what is d and b. Let me read this sentence here. The total amount of energy emitted by a star each second is called its luminosity. Good. The total amount of energy emitted by a star each second is called luminosity, L, which is related to distance away from Earth as d, and b its brightness measured in watts per square meter by the formula above. Okay, so here L is luminosity, d is distance, and b is brightness. So anyway, we are not at all bothered about that. We don't need to like know about this luminosity, distance, and brightness. So here we'll just treat it as some mathematical term. Okay, now read the question. If one star is 3 times as far away from Earth as another and twice as bright, its luminosity is how many times greater than that of the other star? Very what you call straightforward question, but you need to read the question carefully. So pause this video, like when you're seeing again, pause this video, read the question carefully while you're practicing. But now I'll explain you the statement. If one star, here we got two stars. By reading the question, we got a conclusion. We can conclude that we have got two stars, and both are not at the same distance. There is change in distances, and we need to find the ratio of luminosity. We need to find ratio of luminosity for two stars. Read the question carefully. If one star is 3 times as far as away from the Earth as another, that means, let me take star 1. Okay, I'll write here. Let me take star 1. Let it be d1 is equal to, we can take it as 1, and b1 is equal to 1. So L will be 4 pi 1 square into 1. So that will be 4 pi. Star 2. Now read the question. If one star is 3 times as far away from Earth, that means d2 is 3. If this is 1, if this will become 3. One star is 3 times as far away from Earth. So if this distance is 1, this distance will be 3. And twice as bright. If this is b1 is 1, b2 will be twice 2. Now we need to calculate luminosity. It will become 4 pi into 3 square into 2, because we got the formula L is equal to 4 pi d square b. So d is 3 here, b is 2. So that will become 9 times 2, 18. So 4 pi into 18. So L1 is 4 pi, L2 is 4 pi times 18. So we can clearly say that the new star is 18 times greater. We can even get by doing division. L2 by L1 is equal to 4 pi into 18 by 4 pi. 4 pi 4 pi get cancel. L2 is equal to 18 times L1. That's it. So 18 times greater. It is just like doing this cone formula 1 by 3 pi r square h, or volume of sphere, like that. Okay. So we got last question. Even this question is also depending upon the same kind of data. Yeah. Astronomers see two equally bright stars, star A and star B, in the night sky. But the luminosity of star A is 1/9 the luminosity of star B. So their brightness is same. That means B is same, because luminosity depends upon D and B, where D is distance and B is brightness. Brightness is same, no change in brightness, and but the luminosity is 1/9 of other star. That means because of this D. Okay, now we need to find what fraction of distance is from the other star. Okay, so let me take two stars here. star A and star B, star A and star B. So then, since these questions are related to stars, so let me take star coloring. Okay, right. So for star A, B1 is B, B1 is B, or we can take it as some 1, right? We'll take it as some 1 because it will be better if we have numericals. B1 is 1, and we don't know about D1. We don't know about D1. Okay, right. And read the question. Star A and star.
Make it as a big digits.
Okay, so let me take B1 as B1 is same, so no need to take big digit. B1 is same anyway, but distance I'll take big digit. Okay, star A and star B in the night sky equally bright stars. Okay, but the luminosity of star A is 1/9 of luminosity of star B. That means, so from this statement I can write this as, I'll start the problem like this. Luminosity of star A is 1/9. Luminosity of star A is 1/9 of luminosity of star B. So read this sentence carefully. Read this sentence carefully. Okay, I'm highlighting with this color. Luminosity of star A is 1/9 the luminosity of star B. So luminosity of star A is equal to 1/9 of luminosity of star B. So then we'll substitute the formulas. 4 pi dA square BA is equal to 1/9 4 pi dB square BB. So 4 pi gets cancelled, and since BA and BB are equal because they are equally bright, so you can cancel BA and BB also. So then dA square is equal to 1/9 dB square. Now what is asking? The distance of star A from Earth is what fraction of distance of star B? So dA is equal to root of 1/9 dB square. So that will become 1/3 of dB. So the answer is 1/3. The answer is 1/3. Okay. So that's all about proportions. We have covered every problem in that SAT Panda book, and these are important problems regarding SAT. Okay, so that's it.